This video on visualizing weather is designed to highlight some of the sites that show what is happening with the weather. I am a flood engineer, not a meteorologist, so the goal here is just to show some sites that I find useful and how I have used them in the past to understand what is happening. So this first video is what was described as a bomb cyclone that hit the Pacific Northwest in November 2024. It was an extratropical cyclone with a record low pressure that also had an associated atmospheric river. This brought high winds, a lot of rain, and left many without power. Sometimes a picture explains better than the words we characterize an event with, so it is often handy to track down what these events looked like. I'm going to highlight some of these sites and show one by one some of the cool products they provide. This is very much a superficial dive, and I'm providing the links on each slide so one can explore these sites for oneself. The first site here is a NOAA site that shows satellite level pictures and videos of historic severe weather events such as the bomb cyclone on the first slide. Under the tornado phenomena, they even have an educational tool to show how the scales that are used to describe tornadoes translate into damage on the ground to trees and houses. So if you run the simulation, you can adjust the tornado diameter, the pressure, and it shows the EF scale rating of that type in the bottom left corner, and then you hit go, and you can see how that tornado might impact the trees around and the house. There are also many products from the GOES satellites that are interesting to look at the website below. As an example, I'm going to click on the Caribbean, highlighted in the red circle to the left. Since I normally work in the Pacific Northwest, I usually click on the second to bottom link on the far left, but the Caribbean is currently where Hurricane Melissa is, so that is a bit more interesting. There are different products to choose, but as an engineer focused on flooding, I often chose Band 9 that highlights the mid-level water vapor, clicking on the animation loops highlighted in the red circle on the left. One gets a view of the water vapor surrounding Hurricane Melissa at the time I was looking at this, and you can see it going over Jamaica and then Cuba. And then you can see it kind of breaking up a bit in terms of the eye as it goes past Cuba. There's often interesting imagery of the areas impacted, both pre and post event, such as the slider map viewer put together by the BBC from satellite images. So you can see as you scroll from the before to the after, back to the before, you can see the areas that were significantly impacted. I'm not always sure where all the satellite imagery is coming from, but NOAA does have a site where natural disaster imagery can be viewed at the site shown here. Because my focus has always been on the Pacific Northwest, there has often been a lot of focus on atmospheric rivers as they tend to produce the most extreme flooding events in our region. In the region that I worked of Washington, Oregon, Idaho, and Alaska, there are other sources such as thunderstorms, snowmelt floods, rain on snow events, ice jams, and even glacial outburst flooding. But it is the atmospheric rivers that are the most extensive and easiest to see coming from the weather coming in. I've added a quick video made by Scripps describing what atmospheric rivers are in more detail to my playlist under my YouTube station under Flood Perspective, so if you want more details on that. I've also added a short video on El Nino La Nina put out by NOAA's National Ocean Services YouTube page to explain this phenomena, but it can affect our winter weather patterns in the Pacific Northwest. It can affect where the low pressure systems are likely to set up, so it is something to watch with El Nino leaning towards warmer, drier winters in the Pacific Northwest and La Nina wetter, colder winters. But there's a lot of variability in this, so it is still far from predictable. This year is leaning towards a La Nina winter. Last I saw, I think it was a 71% chance. One of the biggest things that I look for is when these atmospheric rivers get pulled into the Pacific Northwest. One site that shows when these atmospheric rivers get brought into our region is this website below from the University of Wisconsin. This video is showing an atmospheric river getting brought into Oregon and Washington in December of 2015. Since I'm not a meteorologist, though, I find myself getting most of my information in areas where the weather is translated for me. This can be found at the National Weather Service's river forecast sites. This is one for the Pacific Northwest. Most of my time is often spent on looking at the river and rainfall predictions, but to start, I do try to get a feel for the weather that is shown on the site. If one goes to the right bar, one can find the forecast precipitation link highlighted in the red circle. If one clicks on that, it gives options to find the forecasted precipitation, but it also has a 10-day temperature and precipitation graphic highlighted in the red circle on the right. If you click on that, you get the next 10 days forecast shown with 4 figures for each day. The left one shows the precipitation, the next one shows the max temperature for the day, then the min temperature for the day, and the one on the far right shows where the snow level is at. In the Pacific Northwest, there's a lot of higher terrain due to the Olympic Mountains, the Cascade Mountains, the Rockies, the Alaskan Range, the Blue Mountains, and the Oregon Coastal Range. And this affects how much precipitation falls and whether it comes down as rain or snow. So what I look for here is both the volume of precipitation, the duration, and where the snow level is at. In this graphic, for day 3 on the far right, it shows that the snow level will be as low as 4,000 feet in the Washington Cascade Mountains. This means if we got any precipitation on day 3 in the mountains, it would be coming down as snow. Even if we get really intense rainfall in that condition, our largest rivers won't flood at extreme levels due to the lack of contributions to the rivers from the upper basin. It can lead to localized stormwater type flooding, though, as the cities are all below 4,000 feet, so the rainfall in the paved cities needs to find a place to go through the local stormwater system. On this graphic, though, there is no precipitation on day 3, so that is not an issue. For day 4 on the far right, it shows that the snow level will be as high as 8,000 to 10,000 feet. What this means is that all of the precipitation is coming down as rain. Due to orographic effects, that means that more precipitation falls as one gets higher in the elevation. The potential for large river flooding is significantly greater if it is accompanied by intense rainfall. Rainfall shown on the graphic to the left on day 4 does show significant precipitation, but when it gets more in the purple or blue color, or the reds, browns, and yellows last for several days, this is when I would usually start paying close attention as the event came in. I will talk about visualizing flooding and their impacts on separate presentations, but I just wanted to give you a feel for how I use some of these sites. There are river forecast centers across the U.S., and they can be organized a little differently. The sources of flooding can be different as well, so there may be other more valuable products to look at as the ones I showed for the Pacific Northwest. These sites can be found at the link shown here. I've talked a lot about NOAA sites, but there are also others that have a lot of information on weather. The University of Washington has this site with a variety of weather information to look at. For example, this is one of the links one can find on this site that shows how the snow is going to accumulate over the next 10 days in the Pacific Northwest. One can see that it looks like the western coastal BC, such as Whistler, may be getting a good slug of snow soon. And then as things progress and you start getting into the 7th, 8th, 9th, 10th, that snow is going to then migrate its way over to Banff as well, and then eventually into the Cascades. Finally, I wanted to highlight some products that can be viewed in Google Earth, as I find it quick and handy to use these products and pretty easy to look at several products at once in this platform. One can also do that with GIS, but I have found for me and my skill set that Google Earth is a little quicker. So if one goes to this site, then scroll down to the QPF section, which stands for Quantitative Precipitation Forecasts, i.e. the amount of rainfall predicted over that duration of time. Click on that time range that you are looking for. For example, one can look at the next 72 hours all the way to the next 168 hours. For this example, I'm choosing the precipitation for the next 7 days, so the day 1 to 7, 168 hour QPF. And if you have Google Earth on your computer, it should be able to open it and provide a graphic such as the one above. One can see the very small atmospheric river predicted in the Pacific Northwest on the top left, and one can see the orange and red to the far eastern extent that is likely the remnant path of Hurricane Melissa going forward. If you zoom in on the area that you're interested in, you can click on the map to see the extent of precipitation predicted for each location. So this was just my attempt to quickly show ways that different sites have to visualize weather and see what is happening. I plan to follow this up with similar presentations on riverine flooding, coastal flooding, understanding impacts from natural disasters, managing weather uncertainty, and other such topics. As always, I'm not the expert on a lot of this, but I'm looking to find a way to share what I know and see what others look at that may be better. I will provide the links shown in this presentation in the comment section below. Please share anything you feel you think would add to any of this, whether it is a critique or an add-on. For similar content, one can visit my YouTube station shown on this slide, and this presentation will be in the Flood Perspective section. Thank you for listening.